Welcome back everybody, I'm Navarrete, and today I'll be going over organic nomenclature number 2. So let's get started. So we're just going to be in charge of finding the name of the following molecules. Like in my first one, I have 1 carbon, I have 4 hydrogens around it, that's what the lines mean. So I know that that's going to be called methane. The next one, well, now we have our OH group attached to that methane, so we just have to change the ending. Adding the alcohol ending, it's going to be methanol. For our next one, this is not going to be a carbonyl. That's just what we call that carbon or that form of bond. We have to figure out what group it is. Again, remember, these are going to be hydrogens. So looking at our flashcards, this lets me know that this is going to be a form of aldehyde. Since I still only have 1 carbon, that's going to be methanol. On the next one, now we still have that double bonded oxygen, but now we have our OH group. So it's not an alcohol, and it's not going to be an aldehyde. Now it's going to be a carboxylic acid. So we just call this one methanoic acid. Next, still have just 1 carbon, so it's going to be a form of methane. But now we have 1 fluorine attached. So name for it would just be fluoromethane or methyl fluoride, just depending on when you learn the naming. For our next one, we have 2 fluorines. So because there's only 1 carbon, we don't have to number where they're going to be. So it's just going to be difluoromethane. On that same trend, now we have 4 bromine. So that's going to be tetrabromomethane. Next one, just changing the halogen that's present. We have iodines instead. So that'll be diiodomethane. Next, well, now we have 3 carbons fully saturated with hydrogens, so we're just going to call it propane. Going on to 10, again, just identifying the functional group. That nitrogen with 2 hydrogens, we are going to call that an amine. So we have our methyl, so just combining those two, methylamine. 2 carbons, we know that's going to be ethane. Now that we have our alcohol group, well, we're going to have to change the ending from ethane to ethanol. For our next one, we have to identify that it's an ether based on the oxygen joining our 2 chains. We have a methyl group on this side, another methyl group on that side. So it's going to be dimethyl ether. Next, identifying again our functional group, that's going to be a carboxylic acid. Since we have 2 carbons, we know that it's going to have the ethane alkane root. So it's just be ethanoic acid. For our next one, again, identifying our functional group, we have our amine there. We have 2 carbons, so that's going to let me know that it's an ethane for my alkane root. Putting those 2 together, it'll just be ethylamine. Next, we have 2 bromines, but they're not on the same carbon, so we have to give the address for both of those bromines. So writing out the name, this will be 1,2 for carbon 1 and carbon 2. Dibromo for the 2 bromines, ethane. Now I started counting left to right. You could have started counting right to left. Notice, however, it would still give that same name. It'd be the same molecule even if you flipped it. On the other hand, now we have both halides on the same carbon. So we would name this one 1,1 because both fluorines are on carbon 1. Difluoro for both ethane. Next, for 18, we have an alkene. So we know that's going to have an ene ending. There's 2 carbons, so we know it's going to be an ethane for our root. And we have 2 fluorines. So the proper name for them would be 1,2 for 1 fluorine being on carbon 1 and the other one being on carbon 2. Difluoro for both fluorines, ethene. Now, however, notice how both fluorines are on the same side. So to be a little bit more specific, we would just add the prefix of cis. So it'd be cis 1,2 difluoroethene. For our next one, we have an alkyne because of the triple bond. So this one would be ethene. Same molecule, but now we're going to be adding a fluorine to one of the carbons. So this would just be fluoroethene. Next one, we have a oxygen double bonded to that carbon. And remember, this is not a ketone. In order for the ketone to happen, it needs to be between two carbons. On this side, we have a hydrogen, so it's not another carbon. So this isn't a ketone, but an aldehyde. So we know it's going to be a propane because there's 3 carbons. Adding the proper name would best be propanol. Next, 1, 2, 3 carbons. So this is just going to be propane. Now this one is a ketone because we have a carbon chain on one side and another carbon chain on the other. So this one would just be propanone. Next up, we have 3 carbons, but now we have an alkene between carbon 1 and carbon 2. So we'll just say propene. Next one, we have a triple bond now. So it's not an alkene, it'd be an alkyne. So it'd be propyne. I know the namings might be a little weird, but it's just practicing. Now 26 is very similar to 18. We still have 2 fluorides. One is on carbon 1, the other one is on carbon 2. We still have that same alkene. So this one is 1,2-difluoroethene. But now on this one, notice how the fluorines are on opposite sides. So this one wouldn't be cis. This one would be trans. So the full name would be trans 1,2-difluoroethene. Next, again, identifying the group. It's an amine. We have a propane chain, so just be propylamine. Next, we have 4 carbons, so that's just going to be butane. 29, we have our longest chain is 1, 2, 3 carbons. We have a methyl group on carbon 2, so this would just be 2-methylpropane. For our next one's identifying our longest chain, 1, 2, 3, 4, 5, 6, 7, 8. So we know it's going to be an octane. We have a methyl group on carbon 2, on carbon 4, on carbon 6. So then the full name for this would just be 2,4,6-trimethyl for the 3 methyl groups, octane. Next, identifying the group. It's a ketone because it's between 2 carbons. So this would just be 2-pentanone. Identifying on what carbon we have that ketone. Because on 32, it's still 1, 2, 3, 4, 5, a pentane, but now our ketone is in a different spot. Now it's in carbon 3. So we have to identify it as 3-pentanone. Now 33, it's not on carbon 4. Remember, we start our numbering on the side closest to that functional group. So we can start it on this side. 2, 3, 4, 5. So this would be, again, 2-pentanone. 33 and 31, it's the same molecule, just flipped. 34, again, this is not going to be a ketone. This has a hydrogen on this side. It'd be an aldehyde. So this would just be pentanal. Our aldehyde is going to be on carbon 1. 35, still have that aldehyde group on carbon 1. So this would also be pentanal. But these 2 molecules are the exact same one, just flipped. Still working with pentane, but now we have an alcohol group. Since it's going to be the side closest to that functional group, that's where we're going to start our numbering. So it'll be on carbon 1. So you can call this pentanol or 1-pentanol, just to identify on which carbon it is. Both are acceptable. On 37, we have the alcohol group, but now on carbon 2. So this would be 2-pentanol. For 38, now the alcohol group is on carbon 3. So it would just be 3-pentanol. 39, starting our numbering on the side closest to that functional group. 1, 2, alcohol on carbon 2, so 2-pentanol. Remember, these 2 are just going to be the exact same molecule, just flipped. 40, now we have a halide on carbon 1, so this would be iodopentane, or another way you can call it would be pentyl iodine, depending on when you learn the scheme. 41, we have 2 iodines. So one that is on carbon 2 and the other one is on carbon 4. So this would just be 2,4-diiodopentane. And even if you started numbering on the opposite side, it would still be on carbon 2 and on carbon 4. For 42, still working with a pentane since we have 5 carbons, but now we have an alkene on carbon 2, so this would just be 2-pentene. 43, we have our carboxylic acid group, so then this would just be pentanoic acid. For 44, we have again that alkene group, but we're going to start our numbering on the side closest to that functional group. 1, 2, so this would just be 2-pentene. This one and this one are the same molecule, just flipped. On 45, we have an alkyne there, so this would be pentyne. For 46, this is going to be our ester. So the ester is on the 3-carbon chain, and then we are adding 2 carbons on the other side of the ester. So the proper name for this one would be ethyl propanoate. Ethyl for the 2 carbons and the propanoate because that is where our ester is. For 47, now we have a 3-carbon chain, and our ester is going to be connecting from this 2-carbon chain. So this one would be propyl ethanoate. Propyl for the 3 carbons and the ethanoate for our ester there. For 48, we have 2 ethyl groups. We have this being an ether, so this would just be diethyl ether. Di for the 2 ethyl groups. For 49, we have our ketone here, since we have a carbon and a carbon chain on both sides. So this would just be butanone, since we have 4 carbons. And last but not least, we have an ester group there. We have a propane group here, another propane there. So this would just be propyl propanoate. And that's it. Keep practicing your flashcards so you're able to identify the functional groups. If you have any questions, don't hesitate to ask. We're here to help. But other than that, stay safe, and I'll see y'all next time.